Salam sejahtera. Welcome to tutorial 1. I am Kelvin Hans Anak from Pkee 1, and today I will present the solution to all of the questions from tutorial 1. Question 1 wants us to find the number of rows and columns, the order of given matrix, then determine which matrix is a square matrix. So here is a matrix A. Let's say it is a matrix A. Okay. It has 3 rows and 2 columns. So the rows are the horizontal lines and the verticals are the columns. So the order of A is 3 by 2. So for B, it has 1 row, 3 columns, hence its order is 1 by 3. Matrix C is a 3 by 3 matrix which has 3 rows and 3 columns. So a square matrix is a matrix that has the same number of row and column. So since C is a 3 by 3 matrix, hence it is a square matrix. Proceed to the next question. Given two matrices which with different order, so A is a 2 by 3 matrix and B is a 3 by 2 matrix. So determine the product of these two matrices. So the operation of multiplication between two matrices is done by first multiplying the first row of A with the first column of B, which result in the first row and the first column of the matrix, which is shown as the at the slide. So 2 times 3 plus 1 2 times 3 plus 1 times 2 plus 4 plus 4 times plus 4 times 4. So repeat this step with the other entries. So we'll get 24, 17, -1, and -11. So first, before we multiply the matrix, we need to determine the order. Here, okay, A has 2 rows, 3 columns, and B has 3 rows and 2 columns. So hence we have 2 rows and 2 columns. So since A has 3 columns and B has 3 rows, so both are the same, so we can multiply both of them. So proceed with question 3. Given two matrices with 3 by 3 matrix, so determine all of the sub-questions. So for question 1, it's very simple. We need to add matrix A with B. So 4 plus 5, 9 plus 4, 6 plus 9, and so on. And we'll get 9, 13, 15, 8, 5, 14, 3, 9, 15. Okay. It is very simple. We just need to add the corresponding elements. So for B, we need to transpose B first. Okay, we focus on the transpose because we already know how to subtract. So for transpose, we need to exchange the row and the column. For example, the first row, okay, 4, 5, 9. So this first row will be exchanged into first column as what has been shown here. Okay, 4, 5, 4, 9, it will become column 1, and then repeat the step with row 2 into column 2, and so on. And then we subtract both of the matrices, and then we'll get -1, 8, 4, 3, 3, 2, -8, -3, 3. So as for C, it is multiplication. So I already explained this algorithm, okay, for them, which will result in 3 by 3 matrix. Okay? We need to multiply the first row with the first column, and then repeat the step, okay, for each corresponding entries, okay, according to the rule given. So the answer is 41, 55, 135, 53, 67, 133, 27, 53, and 91. So as for D, it is B times A, okay, not A times B. So if we multiply B times A with reverse order, we can observe the answer is not the same, okay, which is 57, 97, 139, 18, 41, 76, 49, 62, and 101. So what does this mean? This means that the order of the multiplication does matter in matrix operation. Okay? So whatever we do, we must ensure that we must prioritize the order in order to get the correct answer. So continue to question E. We need to transpose A. So I already explained what a transpose is. We need to exchange, okay, the row and the column. So we have what I have typed here, and then we have the operation of multiplication, and then the final answer is a 3 by 3 matrix because both of them are square matrices. So we get 29, 28, 91, 57, 60, 133, 55, 76, and 157. So proceed to question 4. We have two matrices, square matrices, 2 by 2 of order. We need to determine A minus 5B. Here we are introduced with a new concept of scalar multiplication. Okay? Here, as what I have typed here, so actually for the sake of simplicity, I don't want to like expand the negative sign from 5. I just only need to expand 5 because some some student will always confuse themselves when they include the negative sign into the matrix B. So it is better to leave it there. So we only multiply by 5, okay, on matrix B. So for matrix B, if we do multiplication, we have negative 20, 5, 0, negative 25. Then we can proceed with subtraction between two matrices, and then we get 23, negative 7, negative 9, and 26. Question 5. Given two matrices, so both of these matrices are not square matrices, observe that A is a 2 by 3 matrix, B is a 3 by 4 matrix. Calculate A and B. So first, A has 3 columns, B has 3 rows, so they are matching to each other. So we can multiply the matrix, because if the column of A doesn't match with the row of B, so we cannot do the matrix multiplication. So that's the rule. So hence the product will be 2 by 4 matrix. So we do the multiplication process by doing the linear combination of each entries, okay, of the linear combination of the row of A with the column of B. So that's the key point, the linear combination. Yes, that's the main point. So the answer here is obviously 2 by 4 matrix. 6 minus 3 minus 3, 4, negative 27, 21, 9, and negative 8. So proceed to question 6. So given 4 matrices, so do not confuse the small letter A and the capital letter A. So consider statements below. A is a row matrix. Of course it is false because A is a column matrix. Okay, the small letter A consists only one column, so any matrix with only one column is a column matrix. So row matrix is the opposite. It only has one row. Okay? That is a row matrix, or we can call it as row vector or column vector. So B is A is equal to the transpose of B. It is true because if we do the transpose of B, we exchange the row and the column, we will get the same result as matrix A. So this is true. So C is a symmetric matrix, true, because if we try to transpose C, we'll get the same thing. So the statement in question C is true. So as for the final question, so there are a lot, A until H. So we first begin with A plus B. So this is very simple. We just need to add both of them. We'll get 1, 0, 6, negative 1. So same as B, instead of addition, it is a subtraction. We'll get 3 minus 2, 2 and 7. C is 2A minus 3C, so it involves the scalar multiplications, okay, of two matrices. Okay, first we need to multiply 2 by A, matrix A, and then minus with 3 by C. So we'll get 4 negative 2, 8, 6, minus 3, 12, negative 6, negative 3. So the answer is 1, negative 14, 14, and 9. D is also the same, but with extra step with minus 4c. Okay? 3a plus 2b minus 4c. We do the algorithm as usual, okay, with the involvement of matrix C, and I will get 0, negative 7, 24, and 5. For E, we need to multiply matrix A and B. Okay, we do the not we do the linear combination between the row and the column, as what has been shown here, and the answer is negative 4, 6, 2, and negative 8. Okay, it is a square 2 by 2 matrix. So for F, the reverse of the order of the multiplication is reverse. So expect an answer that is not equal to A times B, which is 2, 4, negative 12, and negative 14. Because we already confirmed that A times B is not equal to B times A. Okay? Not necessarily. Okay, that's the main point. Not necessarily. Sometimes it is equal, sometimes it is not. So G involves the bracket sign, which means that we need to do any operation within the bracket. Okay. So here, the bracket, A times B parentheses times C. So we need to do the A times B first. So do the multiplication, we'll get negative 4, 6, 2, and negative 8. Then multiply it by C. Okay, we apply the linear combination, okay, the matrix multiplication. They will get negative 16, negative 22, 18, and 16. So the final sub question is pretty much the same as G, except that we will do B times C first. So we do B times C, we get negative 3, negative 5, 10, and 12. So observe that when we get the final answer, it is very similar, not very similar, it is exactly the same as G, negative 16, negative 22, 18, and 16. If I'm not mistaken, this is known as the associative law, okay, of the matrix. Or I think it is commutative law. Yeah, it is related between those two. Okay, no matter what the bracket of the multiplication you use, you will get the same answer. So that's all for the tutorial. Thank you for listening.